Welcome, everyone. As you heard from the voice of God, I'm Rick Berke. I'm the executive editor and co-founder of STAT. We launched 4 years ago next week. We're based in Boston with reporters around the country covering health, medicine, life sciences, and we do a lot about, on this very important topic that we're discussing today, new pathways to neuroscience breakthroughs, the good and the bad we write about. And we have, and in that 4 years, there's been quite a tremendous growth in the field. Unfortunately, though, I think we've all seen there's also been a lot of confounding, frustrating news about like why hasn't there been more progress. Just today, I noticed the Milken Institute projects doubling the Americans living with dementia, and over what period of time? Over, you know, I can't.
I believe it's 30 years.
Okay. Either way, the numbers aren't good. So we have a ton to talk about. The brain-based illnesses and injuries are the leading cause of disability worldwide. But one of the things we want to discuss today is that professionals lack the tools to diagnose and treat these illnesses. We have, as you can see, a very high-powered group here to dive into this, and without further ado, I'm going to ask everyone to speak very quickly as an opener to tell us about sort of what maybe one of in their view the one biggest challenge is in this field. And I'll start with next to me, Cara Altimus, director of the Center for Strategic Philanthropy at Milken Institute, who's based here in D.C.
So as we look across the landscape of brain-based illness, we have the privilege of working both on the neurodegenerative disease side and psychiatric illness. And as we've gone through this, we continuously see that the way that we diagnose and define the brain-based disorders is very convoluted, in that we see overlapping symptoms, we see high comorbidities, and as we try to unravel what is what in the area, we see that as one of the greatest challenges, that if we can start to crack it in one space, it will propagate to the rest.
And now let me go to Jeffrey Bornstein, the president and CEO of the Brain and Behavior Research Foundation.
Thank you.
Based in New York.
In New York, yes. But we're really national and
Right.
international in scope.
I just want everyone to know we have an international panel, people flying in from all over the place.
Right. 9-hour time difference for the conference call. I think going off what Cara said, being able to develop improved ability to make a diagnosis through what we refer to as biomarkers, so that we can potentially find physical markers that could help us make a diagnosis, and an early diagnosis, or even figure out who's at risk. Because we as a field have not done prevention. If you think about cardiology, cardiologists do prevention. They treat high blood pressure, they treat cholesterol, they tell you to diet and exercise, proper diet and exercise. We as a field for brain illnesses have not really done that, and that's extremely important moving forward.
Next we have from Seattle, Niranjan Bose, the Managing Director of Health and Life Science Strategies for Gates Ventures.
Well, thanks, Rick. Thanks for having me here. I think to your question on one of the greatest challenges, I would posit that we need a mindset shift on data sharing. Retrospective data sets, prospective data sets. I think having access to broader clinical data sets could be a great breakthrough.
And finally, from Brussels, Dr. Johanna Striefer, Vice President and Head of Translational Medicine, Neuroscience, Early Solutions, UCB Biopharm.
Thanks, Rick. I would like to thank you and the Milken Institute for the opportunity to be part of this panel. Already been very inspirational in the preparation, so thanks for that. I want to follow up on some of the things that were said specifically from Jeff. I mean, if we don't detect brain diseases really very, very early, and I mean decade ahead of the clinical picture, we will not be able to treat it. So therefore, I think the early detection of specifically neurodegenerative diseases will be key for any successful way into doing something positive for the patients in the long run.
And before we go any further, I want to sort of set the mood and the tone for this discussion visually. We ran something in STAT that I want to show you on the screen. Mass General came up with the most detailed 3D image of an intact brain ever seen anywhere. And I just want to show it because it's pretty cool, if we can get it. No, I see it. I'm looking on the.
We're still impressed.
So when you see this, what do you think? What do you all think?
I get immediately excited. I think one of the things that we're seeing right now in the space of neuroscience is that we're able to start measuring whole brain changes, morphology, activity, both with optical imaging as well as electrical activity, and we're able to do that in a situation where people are actually behaving, and we're able to do it with molecular specific markers, which will lead to these very specific biomarkers, which will help us understand all of the facets of what we characterize as neurodegenerative disease and psychiatric illness, and where in the brain it's happening. And so as we move towards a world where we can understand the details, I think we will have a much better understanding of what is similar and what are the unique differences, and how do we diagnose and treat.
Other?
Yeah, you know, I also find this exciting, and above and beyond the actual science of it, is it brings us back to an important point, and it goes to the challenge that we face, which is stigma and prejudice against these illnesses and about these illnesses. And this image basically reminds us that all of the conditions that we're talking about are diseases of a particular organ. That organ is the brain. And it's not due to moral weakness, it's not due to character weakness, nobody decides they want to have depression or bipolar disorder. It's due to an illness in that organ. And as we better understand how that organ works, we're going to be able to develop new methods of treatment.
Looking at this, and obviously it is fascinating. As a neurologist, we started seeing MRI images in the training, and they are getting better and better, and this is what we see today. We as well have to realize that the technology needs interpretation and needs adaptation into the field. Like with great power comes great responsibility. Mm-hmm. So when we see these images and we don't know what we're seeing, then they are much less useful than if we do that in a consistent, longitudinal way, we understand it. As you all may know, when the first MRIs came and the researchers themselves went in, they found lesions in the brain and realized some of them had MS, and then later they found some of them didn't have MS but had the lesions. So it's a pendulum swinging on both sides. We get very excited when we see the images, but we have to get to understand what it really means.
Let me take everyone back to, do you remember that Obama used to be president? It's hard to take you back to that period. But the reason I bring this up is I want to take you back to 2013 when President Obama announced his brain initiative. There were very high hopes for the development of technologies that might shed light on the cause of brain disease or even cure them. Obama said that between the ears, quote, there is this enormous mystery waiting to be unlocked. And he went on to say this will give scientists the tools they need. Well, in the 6 years since that was announced, what have we learned? Has that worked? It doesn't seem like scientists have gotten the tools they need. Has that worked or not, or what's your reaction?
If you just think about tools, I have the impression the tools get better and better and better, and we're trying to catch up and to understand what it means. So now we have this image. Now you think back into all the epidemiological studies done, they had lesser images. Now you would like to have this image for all of them. If you think of genetic testing, like 10 years ago, it took a village and a year, and now it takes a minute and a drop of blood and, I don't know, a few bucks. So the same will be with wearables. Wearables will put us in a completely different position. We will be able to understand really what's going on with a patient over a longer frame. And there are a lot of these technology changes, but we have to learn to use them right. The technology is not good enough. You as well have to have the right application.
More specifically, was this Obama administration approach the right approach?
Oh, I think we're all being too polite and waiting for everyone else to speak. The Obama administration and the Brain Initiative is focused on tool development. And I think in the space of neuroscience right now, as I mentioned, just seeing this is exciting because we're able to start taking whole brain approaches to understand what's happening across the brain. And it is, we need the technology to be developed to do that, to be able to start seeing how we all behave in the real world and what is our brain doing and how is it responding. I think as we build that out, we need to also be paying attention to the diagnostics and what are we learning here and how can we transfer that to really understanding the conditions of the brain and how we treat them. But we're probably not there yet. And so the build out of those tools is, I think, really necessary.
Yeah, I think, first of all, I applaud President Obama for doing that. It was significant. But I don't think the science is at a point yet where we could have a decision made from the top down to say, okay, this is the path, this is the answer. We're not yet there. So it also needs to, in addition to that, include ideas that are coming from the scientists themselves. New ideas, new approaches. That's really how innovation can occur. So we really need a few different approaches, whether it be the large top-down or just individual scientists and labs saying, hey, we have a new idea, a new approach, let's bring that to the table. So we're still at a point that we need all of that.
Yeah, and I think we need more shots on goal. That was one shot on goal. We need more shots on goal. And it was a good shot on goal.
Mm-hmm. And you can take you might get people dizzy afterwards, so we can take that off.
Having seizures.
Obviously, we're all like really focused on Alzheimer's and what's happened and the ups and downs. And as you all know, the last drug for the disease was approved in 2003, and no drug now slows or stops the disease. But the dominant amyloid cascade hypothesis has been around 30 years. Why has there been so little progress?
I'll start. I'll give you maybe a naive perspective. We've been at this only for about 3-4 years trying to understand the space, so take it for what it's worth. I think the organ that you're trying to study is a difficult organ to understand and truly get a good picture for the pathobiology. I think that's been one of the biggest challenges. And the second is, I think the diversity in the pipeline was lacking maybe 2 decades ago. You're starting to see diversity emerge, but I think a decade or two perhaps was missed.
Is there two, when you talk about sort of the diversity, we did a big project that Sharon Begley, one of our reporters, did on sort of how we ended up here after so many decades. And she had many people, this wasn't her word, but many people said there was a cabal in among scientists, academics, just government, where people didn't want to hear other solutions or other paths, and that's what slowed us all down. Do you agree with that, or what's your take on that?
If you looked at where the funds have gone and the number of candidates in the pipeline and take an objective view rather than take one side or the other, I think the numbers speak for themselves. Yes, we overinvested in 2 hypotheses.
And did you see that at the time, or I mean?
It's retrospective. Yeah. Hindsight is 20/20, so it's hard for me to say were the people who made the decisions right or wrong.
And why the overinvestment, and how do we make sure that doesn't happen again, whether it's in Alzheimer's or other disease areas?
Maybe. So I would like to take a step back, and maybe it wasn't an overinvestment. I want to be very careful because obviously I'm now in drug development, 12 years in the industry. I've done academic research before that. And I'm, in principle, grown up with the amyloid cascade hypothesis. Now, the amyloid cascade hypothesis is very solidly founded on the genetic findings. I mean, all the genes related to Alzheimer's disease all point to amyloid. Now, we learned a lot, and I think that is where we have to stay humble. Maybe we haven't yet even now learned enough. We realize that if you have a genetic change in a sporadic disease, that may be a very, very early event. And maybe it's not the right treatment. It's just the amyloid cascade hypothesis told us this has to be at the root cause of it, otherwise not all the genetics can point to it. And if you think about a lot of we want to understand the disease, then that is hypothesis free. The treatments, obviously, over the last, let's say, 7, 10 years, 15 years, were very amyloid focused. That's true. But then on the other side, this is a very difficult beast to tackle. And I don't know how you followed that, and obviously I can't comment too much, but on the last phase 3 results are now conflicting information, where initially it says we have to stop the program for futility, we don't think about it. Now we believe there could be something in just saying this is not easy. It's not an easy shot on goal where you say this is what we want to do, this is what we see. And just for the amyloid cascade hypothesis, it still was extremely helpful and valuable for us to develop the biomarkers even for the initial phase. So maybe it's not our treatment success, but at least it helped us in moving forward in the understanding.
I think building on that, and maybe a slightly different viewpoint, is that while we did learn a lot, we need to make sure that as we're moving science forward, that we are fostering a diversity of ideas, and that we're building some of the science behind, so that when there is a failure, when we do need to move past a path, or maybe we will come back to it, that we have other science, other hypotheses that are coming along behind it that have been built up enough to begin to move forward faster, which speaks to some of Jeff's comments around we need some bottom-up, some basic hypothesis and idea testing. And so you have to nurture the scientific community and be kind of planning from above and moving in a two-way approach.
I think, it's easy to be a Monday morning quarterback, but I think moving forward, what we're saying is to get that diversity of ideas and support scientists. And the other piece is it's very, very hard for a person to begin a career in science, especially brain science. So we need to do a better job nurturing young scientists who are interested in the field to really help them have a path to developing a career in brain science.
I'm a young scientist. What's the pitch you're going to make? I don't feel like a young scientist. What's the pitch? What's the pitch to me of why I should do this? When the answers have eluded us for so many decades. What's the pitch?
Great question. The reality is, for young scientists, they don't need a pitch. They get it. They're excited and interested in doing this. We as a society put up every roadblock possible to make it difficult to do so. The young scientists are excited by the field, see the promise. When I went to medical school, I was taught that old brains don't grow new cells. That was the science, and old was after the age of 2. We now know that's not true. That through a process called neurogenesis, old brains, including everybody on this stage's brains, grow new cells. And so the science changes. And I think young scientists are very excited about the field and coming at it from different directions, from neuroimaging, from studying stem cells, from genetics, from a variety of approaches that together is going to make tremendous progress.
Let me ask you, one of the biggest stories was last week, as we all know, when Biogen said they're going to reopen these Alzheimer's experiments. And the story that really got my attention that one of our reporters, Adam Feuerstein, did was the day the news came out, he talked to nearly a dozen institutional investors, and he talked to them anonymously because they didn't want to be quoted saying this, but every one of them said they don't really believe this will work. Every one of them. And And one of them said, this is like corporate 3-card Monte. Let's see, we don't have anything else, let's see. What do you make of that? What's your reaction to what these investors are saying and to your reaction to what Biogen is doing, reopening this?
The first thing is we need to be investing in de-risking other pathways and targets. I mean, for the comment, the one that you ended on, it just says, it speaks to how much we need other pathways forward, so that when Biogen or any company moves forward with something, we're not seeing that as they're just doing the only thing available, but that they're choosing amongst path.
Yeah, I think take the investors' hat off, and I think we owe it to the patients, the families, and the caregivers who participated in that study and a lot of other studies. So we need to look at the data closely. It's hard to speculate from outside whether it's going to work, not work, but it gives me optimism.
And obviously, I don't want to comment on the particular case, but I think there are a few things that come to mind. The one thing is, can we look at neuroscience drug development specific for chronic disease in a similar way as we do it for other diseases, where we do phase 1 healthy volunteers, a study to de-risk the mechanism and give us some confidence, and then go into phase 3. And that will be very difficult if we don't even know how long it will take to, let's say, to stop a neurodegenerative process. As of today, we have no disease in a neurodegenerative process where we stop the process. We don't know how long it takes to put on the brakes in a train running fast. So that's one thing. The other thing is when we have these trials, and we do now a lot of very innovative trial designs, we do futility analysis and adaptations, and we take risk in that, is it? Because what we do is we take decisions on incomplete data. The data set would be complete at the end of the study. All the other things is taking risk. And what we now seemingly here have is that they revert that position. Now, I can't call on the specific case, but we have to keep that in mind when we design trials, when we ask patients to participate in trials, when we try to develop solutions. Maybe we have to think these profiles different for neurodegeneration and long chronic diseases.
Let me ask you, just to look more broadly at the players involved in finding some of these answers. What, if anything, has philanthropy done better than the NIH in terms of funding brain research?
You want to take it first?
Sure, I'll go first. One of the challenges for researchers, especially young researchers or more senior people with a new idea, is when you're getting funding from NIMH, for the most part, you already know the answer to that research protocol, and you're just proving it with a larger N. So one of the things that philanthropy can do, and that Brain and Behavior Research Foundation has done over the years, is support scientists with a new and innovative idea so that they could develop data and then go get the funding from NIMH so that they get a foot in the door. So, and it's very much like a venture capital kind of fund doing that. So I think that there really is an important collaboration between philanthropy and government support that sort of allows the flow of science to move forward in that way.
So within the Center of Strategic Philanthropy, as we help foundations in this area, I feel like we also get to kind of study it. And so what Jeff has mentioned is this kind of startup fund. But I think philanthropies do a couple of other things that are really important in this space. So the Kavli Foundation is a really good example where they, before the BRAIN Initiative was fully baked, they brought all the key players together. They brought government, they brought researchers, they brought policymakers all together. And that's really where the idea and the plan came from to make the BRAIN Initiative real. Another key thing that we see philanthropies do that's really different is it's around data sharing and collaboration. So we have a collaboration with the Fox Foundation right now, and the whole idea is to change what team science means in neuroscience, and to bring more types of disciplines to the problem of Parkinson's. So those are, I think we've covered 3, but there's more.
Yeah, I would say, from our perspective, I would say it's risk and de-risk. So risk being, it's a matter of being, it's a time risk. We don't wait for a peer-reviewed opinion to come out, no scoring. If we believe there's an idea that needs to be tried and tested, we can accelerate funding that within a matter of weeks. That's risk. I'm not saying it'll succeed, but it's worth a shot. De-risk is the venture capital model. When there are companies or academics trying to spin out a company, for them to go out and raise capital in the private markets, it's probably hard until they have preliminary data. But philanthropy could de-risk.
In terms of
Maybe
yeah.
just say, because I like all these points, this is very important. I would like to highlight one of them, and that is how you talked about it, Cara, bringing people around one table. And we should not underestimate that. It's so important to have the right people speaking with each other in an atmosphere of open sharing. And that is one-to-one sometimes difficult. It's specifically for pharma. It's very difficult with other pharma. But it can be very nicely facilitated in this type consortia, roundtables, initiatives. If you see what Michael J. Fox Foundation is doing, it's gorgeous. If you look at the ADNI study, which as well was NIH funded, but then there was the Alzheimer organization in. So that helps us to come to the table and speak very openly around the science and really create this pre-competitive atmosphere what we need. I mean, we need to get around the table all together.
Ranjan, let me get back to you. Speaking of philanthropy, your boss, Bill Gates, is obviously passionate and committed about global health and a lot of other things. Where does the brain research fit into his passion and his interests?
Yeah, so our journey in this space started maybe 3.5 years ago, and why we got interested, beyond the personal connection, his father having Alzheimer's disease, if you take the personal connection out, objectively, one of the charts we often look at is the global burden of disease data that comes out on an annual basis. You look at US, 2000, 2010, 2015, the only disease condition that's going up in the top 10 for which you have no prevention, treatment, or cure is Alzheimer's disease. And then you ask the question, what's today's US healthcare spend of 3.6 trillion or 3.7 trillion? Where are we going to be if we don't solve this problem? Unlikely a bigger train wreck. So that's what got us interested, and that's where this fits in for us. It started purely as a curiosity experiment, and now here we are having committed close to $150 million. So I think it's going to grow for us.
Is there, and that's a lot of money, but it's a drop in the
It's
bucket.
a drop in the
as
bucket.
you've
Absolutely
said.
drop in the
So-
bucket.
So here you have, just practically speaking, one of the richest men in the world. His father had Alzheimer's. He's deeply concerned. This is an intractable problem. Why didn't he just throw everything at it?
Yeah, I mean that's a
I mean,
that's a
well,
great
seriously.
question. That's a great question. But I think the approach we want to take is where are the gaps that philanthropy can fill or catalyze? Look at the NIA budget. With $2+ billion, does adding 2 more make a difference? If there are great ideas, we want to hear those great ideas. If you doubled it, will you magically diversify the pipeline in 3 years, 5 years? If there are ways to do that, we'd love to hear those ideas. So I don't think throwing more money at the problem is going to get you the answer we're looking for in the short term.
It's not a drop only. I mean, if you think about what you can do it, if you look at the natural history studies that have been funded, I mean, this is the type of money that really can give science the first step into the door. I mean, moving it. I don't think, or I do think that this support is very important, and we shouldn't dismiss it. I know you don't want to say that, but the overall healthcare cost obviously is like the threat. This is what drives us. If we take science seriously, we would need much less to make these steps. And I think we have to more understand how we bring that all together. Is it so?
And I would add one other thing. The philanthropy is critical, but I think the sovereign wealth funds need to take this issue more seriously as well, as they start to face aging populations and dementia in their countries.
there's a lot of talk about psychiatric illnesses like depression, bipolar schizophrenia, and how they exist on a spectrum. How can that help or not help scientists discover treatments? I mean, how does the spectrum come into play here?
Great question. And in many ways, it goes back to that biomarker question, that when we say schizophrenia, it's not one illness. There's a few different schizophrenias, and we are not yet at a point of being able to categorize them specifically. Same thing for depression, same thing for bipolar disorder. So the sort of spectrum of these conditions is an added part of the challenge of understanding them and developing treatments that are right to each individual.
A really good example of this, I believe it was within the last year, there was a study that looked at brain imaging in depression and identified 4 subtypes, and very specifically based on those could determine who would respond to a very specific type of neuromodulation. And that begins to show that there are multiple types, and that as we are able to better unravel who's who, that we will be able to match them to the treatment that will work for them, which is ultimately what people living with these conditions want. We did a survey of almost 6,500 individuals a year ago, and probably the most common response amongst that was the lag time and the guessing game. So people felt like guinea pigs as they were trying to receive help in the mental health space, because they would go through many different therapeutics, wait 6 weeks for each one, not know if it was working, does it continue to work? And so the more we can use biomarkers, know what we're dealing with, and then match to the right therapy, to the right part of the brain, we'll be able to I think, give hope and confidence to the community.
To follow up on what you're saying, Cara, I'm a psychiatrist and I treat people. And I don't know what medicine is going to work for someone. There isn't a blood test for that. There isn't a brain scan for that. I have to use clinical judgment, and sometimes I'm right and sometimes I'm not. But work is being done along those lines. I'll give you an example that I think is exciting, which is the use of stem cells. So being able to take a skin sample, turn that into stem cells, and those stem cells can be turned into brain cells. So we now are able to have the person's brain. We're not going to go into their brain and take a piece of brain, but this is the next best thing to doing that. And ultimately, a patient's going to come to my office, and I'm going to want to get their brain cells in this way, and that's going to help me decide whether or not it's Zoloft or Prozac or lithium or Depakote or what the right choice of medicine is. And that's where we're moving. And that's because of the different approaches of science to understanding the brain.
Just to add to that, I mean, you're now talking about those that already made the way to find you in your office, is it? And when we talk about the spectrum, then we as well talk about those that struggle for a long time before they even ask for help because they don't know if there's help needed or not. And I think it's really about listening to the people, the patients, because there is a spectrum from non-diseased into diseased where they need help. And potentially you have to do that retrospective. Take lessons learned. I mean, it took you how long? What was it initially? And I don't think we do that systematically in a moment. We treat those that come into the office, but we struggle to help those that haven't yet figured it out. And we are not very good in helping them to figure it out.
For bipolar, we know that it's a 9-year lag between symptoms and help.
Mm-hmm.
Similar for schizophrenia. Mm-hmm. It is really one of the biggest challenges in our field, and for families, loved ones, and obviously for the people who are living with these conditions. If you think about any other medical illness, if it took 9 years for treatment to occur, it would be on the front page of the Times. If that was the case for diabetes, it would be on the front page of the Times. So we need to do better.
Mm-hmm. It sounds like you need to have a lot of patience.
In two
Both.
sense, so, yeah.
I would say both of those words.
In both of them.
So let me ask you this. Last year, Pfizer got out of the brain development business completely. There were 8 neuroscience drugs in clinical trials that spun off. Is there 300 jobs cut? Is the field so hopeless that that was the right business decision?
I don't know if anyone can speak to the business
Well, not
decision.
that, forget I said business, but that's pretty dramatic what they did. And why would they do it if, I guess I'm saying, is the field hopeless? And that seemed to be the signal they were sending.
I don't think it's hopeless at all. I think there's a lot. We're seeing development in other smaller companies and certainly throughout science. I think maybe Pfizer felt like they weren't the best position to do it now, but maybe you guys can follow up.
I think objectively, if you look at it from a financial angle, I think they took the right decision to exit. They felt they were not having a competitive advantage. Their capital was getting better returns in other therapeutic areas. So do I agree with that decision from a patient perspective? No, but if you're a shareholder, I think they did the right choice. But is it a hopeless field? No, absolutely not.
Yeah, there's tremendous hope. So I think what we saw over an extended period of time is that a lot of the drug companies developed what's referred to as Me Too medicines. So basically it was a similar medicine to the last one, didn't really do that much different, and they could then sell the brand name instead of the generic. And it didn't really add that much to treatment. We're now seeing some real breakthroughs and changes in the mechanism of action of the medicine. And to me, one of the most exciting things are the rapid-acting antidepressants. So instead of needing to wait 4 to 6 to 8 weeks for it to work or not work, a rapid-acting antidepressant works in a few hours. And if you think about it, it's a game changer. So somebody is depressed, maybe at risk of suicide. They go to an emergency room, and instead of being admitted to the hospital for 2 to 4 to 6 weeks and interrupting their life, they could get this type of medicine and go home safely and continue treatment on an outpatient basis. It's a game changer. They could go to school the next day. They could go to work the next day. Their life isn't interrupted. And we're just beginning to understand the mechanism of action of these rapid-acting antidepressants. The ones that are available now are useful for a number of people, but down the road, there's going to be newer ones developed based on that same mechanism that won't have the side effects and will be even more effective and will make a big difference.
Yeah, I mean, I think the key here is that the newness of pathways, that diversity that we've been talking about. And I think the other one that's really exciting, and I say this as a woman, is thinking and working on the postpartum depression and that understanding mechanisms there and developing new therapeutics that will specifically help that moment, they will be life-changing.
Obviously, it's difficult. As a scientist and drug developer in pharmaceutical industry, it's very difficult to see another one leaving. I mean, in all other industries, they would say, yeah, less competition. It's different here. It's really different. And I think what it means is we need commitment as well for the companies. There's a lot of commitment. We want to do this. Why is there so much commitment needed? Because it's very difficult to de-risk neuroscience projects early. You will have to wait long, you will have to invest long, you have to have that stamina and go for it. This morning in a panel, actually at 7 was very early for me, I learned that what I do is risk-taking and that invention is later, so difficult. But I think what I learned from that as well, there is a lot of risk-taking. And the question is, what can we then do to make that risk-taking more possible? So allow companies to go for the development, allow biotechs to go into the development, allow the field to have investment funds, the willingness to fund neuroscience research, because we shouldn't only talk about Pfizer dropping out. That's a signal for other investors as well. That would be the most devastating thing to see, that there is less focus on solving these problems. So as a field, we have to try to de-risk the pathway and de-risk. And I think a lot of the stuff we discussed here earlier can lead to that.
So what would your pitch be to Pfizer of why they need to get back into this?
Again, I don't want to directly comment for competitors. I leave that to others.
So I think history speaks for itself, right? When Pfizer sees the opportunity to get back in, they go acquire a company. So we need to diversify the shots on goal. The small companies that are now working become bigger, they become more promising, there's promising data. Very likely they'll get bought out by a Pfizer or somebody else.
No, that makes sense.
What I would say to them is, unfortunately, you have a lot of potential customers out there because these illnesses affect many, many people. So if you can be a part of developing a new medicine that's more effective, you're going to make a lot of money, and you're also going to help a lot of people.
Makes sense. There's also a lot of talk about big data in neuroscience and the challenge of analyzing terabytes of information. Why should we think that answers that will lead to cures are in these big data collections? Or should we think that?
I would say absolutely. I actually want to highlight, I recently learned about an initiative that they're doing in Ontario where they're connecting the same data collection across, I think, 5 unique conditions: epilepsy, neurodevelopmental, depression, and I'm not going to remember the other 2. But in doing that, they're going to be able to understand what are these specific similarities and the specific differences in the brains and genetic makeup of the individuals living with those conditions. And we will begin to understand why we see high rates of comorbidity, why we see depression being a major risk factor for dementia, why we see epilepsy and neurodevelopmental disorders co-aggregating. Those are going to be really important findings that currently we give 2 diagnoses to, but maybe this is across a continuum of brain changes.
You know, there's been tremendous work, and this goes to the idea of sharing information, which is so important in the genomic studies, where scientists from around the world pool their data, because you need a lot of data to really see what they refer to as a spike, and they refer to it as the skyscrapers. So you could pick out a gene or a second gene or a third gene that's associated with schizophrenia or bipolar disorder. This isn't to find the gene and the cure with the gene, but by understanding some of the genetics of it, it points to areas, proteins that may not be being made, other areas of potential treatment for the person. And that's a great example of big data and collaboration providing good science.
Yeah, Rick, I might just make a tweak to big data and just take the words big out and just say data. Because I think we might run the risk of every other sector having gone the way of saying big data will have the answers to what we need. The more important thing is, what are the questions that we want to ask with those data sets?
Yeah, like that very much. I mean, we had the technology earlier. It's how do we apply the technology? Data is technology for me. How do we apply that? And we talked about early diagnosis. If we don't have very long longitudinal data, we will never understand this. If we don't know how somebody has developed over the last 15, 20 years into this disease, we will not understand how we can go in earlier. I think data is really the point. How do we share data, analyze data, get it together? And I'm very hopeful for that, because there is a lot of attention to that. Data sharing is getting much better. You had good examples on that, how you're facilitating it. So these are good things. Big data is a big buzzword. Artificial intelligence, we can put it on there immediately. But I think for artificial intelligence, similarly, we can have it completely freewheeling, or we can ask questions, or we can have a smart combination of the 2. And I think this smart combination of the 2 is what we're currently needing.
I think one thing to note, we, as I mentioned, we have this luxury of kind of working across neurodegenerative disease and mental health. And Parkinson's has this beautiful case where they have, Fox Foundation and steering committee has been leading imaging and genetic study almost for a decade now. And I'm sure I'm going to butcher the stats here, but they have thousands of people that they have tracked the progression of their brain and their symptoms, and they planned that progressively so that we, across the world, across centers, collected the same data the same way and are able to study that in a really meaningful way. And in other areas, what we've seen is existing studies kind of cobbled together, and that's better than nothing. But I think where we're able, as a group in this room of funders and decision makers, is we're able to bring the right people together and develop the prospective, put it together in a really intentional way so that it is coordinated, it is collected similarly, put in the same place, open for multiple people to engage with, so that it's not just one person's idea, but we can get some of the bottom up. That's going to make such a difference in our understanding across illnesses, and we can use that Parkinson's example as a path.
I want to just add about data, which is a real opportunity. Over the years, if somebody had depression, let's say, or bipolar disorder, they would go to the doctor or other treating professional once a week, once a month. They'd report how they are that day and move on. There's the opportunity now with monitoring people's sleep, monitoring their activities, monitoring, again, all with their permission, monitoring their use of social media to see how engaged they are, to really follow people's lives over time and maybe see an early warning sign that somebody might be getting ready to relapse. Maybe they're not sleeping as well and they don't realize it, but the monitor does. And I think that kind of data can be very, very useful in helping people moving forward.
Let's now go, in our remaining minutes, let's go to questions from the audience. Yes, sir. Please, obviously, identify yourself.
My name is Mike Belleville from Dementia Action Alliance. And something that you touched on a little bit was about patients and getting patients needed for trials. And what I keep hearing, specifically for people with dementia, is the roadblocks that it takes to even get into a trial. And I'm hearing how we always need more people, we need more people, we need more people, but the protocols and the things that are set up to get the people into these trials are so difficult and stringent that I mean, is there a way to lessen that, to make it easier for folks who want to get into trial to actually participate?
Thank you. Who wants to take that?
I will give an example. We, in the past, worked with an organization called Cure PSP, and they were really focused on a specific neurodegenerative disease, but I would say around the world, they worked with and rallied around and made the connections, and it took a lot. It takes a lot of effort, but that's coming from the community side. And I think what you're asking for is, are there ways that we can change the policy, the infrastructure, to make that more doable? In dementia, I think it's particularly difficult because you are managing caregiver and patient needs to make it happen. And so I think we've seen places where community and philanthropy kind of fill in the gap, but the question I think remains, can we change some of the policy and infrastructure to make that more doable? And I think technology will be a big part of it, but I'm sure you guys have thoughts too.
No, I hear you're talking about stringency of inclusion criteria, and that obviously is something we always challenge ourselves, like take in the bare minimum. Is it describe the disease and have everybody participate as much as possible? On the other side, we were talking about targets and a molecular mechanism. So when you have a molecular mechanism you want to go after, you may potentially want to use a biomarker to identify this is even applicable in this one individual patient. And I think that's where we have that balance, that early on we want to be very targeted to even understand the de-risking. Does our drug do what we want to do? And then later on, obviously, we have to demonstrate it will be applicable for everybody. But early on, at least how my feeling is, you have to be very targeted to understand your drug well, and then you have to be broader and get it to the right people. I hear you, and it's a very difficult thing, and we have lots of discussions on that point.
Yes, sir.
Hi, David Moncho from UC Berkeley Institute for Data Science. There was a comment, Jeffrey, you made earlier that I just wanted to go back to see if I could understand better. You said that young scientists, it's very hard to get started for young scientists. And then I think Cara made a comment about the importance of diversity in team science. So what's keeping it from, I don't know what you mean by, what are the obstacles to young scientists?
Yeah, great question. Thank you for asking that. The biggest obstacle for young scientists is getting the support, getting the financial support. It's hard to get government support. It's hard to get philanthropic support. So it's getting the support. And the challenge is for all scientists, and one area that's especially challenging is for people who are more clinically oriented. So the number of people doing research who are MDs or MD PhDs versus PhDs who may not have as much direct clinical involvement, that's been decreasing over time because the MDs are required in an academic setting to also do clinical work as a part of their day and a part of bringing in the revenue. So it makes it even harder for them to get that pilot data and move forward. So it really is our funding mechanisms that get in the way of young scientists. The age that a scientist gets their first support from NIMH has been increasing steadily over time. That's a challenge.
Yes. Why don't we wait for the mic over here?
Hi, I'm Janet Knupp, and thank you very much. We're all talking about a pharma cure and how we can do that research. Can some of you comment on cognitive stimulation? As you probably are aware, in the United Kingdom, it's mandated that you get cognitive stimulation if you have any form of dementia. And in many other countries, in Canada, Australia, we use cognitive stimulation as an evidence-based practice, but in America, we don't really talk about it. So I'd love to hear you talk about cognitive stimulation.
Perspective of clinical trials, you often have to do the one or the other as a controlled condition. That does not mean that in a care situation, you obviously have to mandate that. And I think there are a number of things which we now know, they are just good for your brain, and physicians should know they're mandating moving it forward. Now, cognitive stimulation will not cure Alzheimer's disease. Cognitive stimulation will help you to cope better with it moving forward. So I think it's absolutely important that we're aware of it, that physicians treating patients use it, but it will not replace a curative treatment.
However, I think, what we're really saying in general is it doesn't necessarily matter what the therapy is, whether that's cognitive behavioral therapy or early exercise. It's that we understand what is happening in the brain, what are appropriate interventions, and that we can measure and understand kind of start to finish. And what gets us in the middle, science will help show what that right thing is and that it's working. And I think in general, you always want to do the minimum required to get to the right place. And so often we, across brain diseases, start with the easiest intervention and build up. But right now, we don't have a really good way to know that it's working.
We have time for two more very quick questions. Yes, ma'am. Right over there, yeah.
I'm Jing Liu from University of Michigan Data Science Institute. I want to go back a little to the basics, to the foundations of neuroscience. By training, I'm a neuroscientist, and I feel like in the past years, things are happening in larger scale, faster and bigger, but fundamentally, conceptually, what we understand about the brain is still very limited. So I wonder, foundations, philanthropy, what you think they can do to contribute to a conceptual progress.
It's a very good question. And it goes to really the importance of basic science, because a lot of what we've been talking about today has been more clinically oriented. And so the basis for that really is basic science. And we need to, in addition to everything else, also keep our eye on the ball of supporting that basic science so we can better understand the brain. And going to the earlier question about 6 years later, why? Well, it took 10 years to get to the moon, and this is a lot more complicated. And we need the basic understanding of the brain in order to get to the moon.
Yes.
Ian Kramer from the LEAD Coalition. Back to the point about bringing in younger researchers. I think the test case is NIA and Alzheimer's. Part of the reason that we in the advocacy community have worked to quadruple Alzheimer's research funding in NIA is not only to diversify the range of targets, but specifically also to bring in younger researchers and researchers from other fields of study. And that's exactly what NIA has been doing with the money. They've created a Young Investigator Fund. They've shared their resource with other institutes to bring in new lines of thought. Researchers are economic actors just like Pfizer is. And the proof is there that you are getting those results from NIA. So I think the point is, how can we do that not only in Alzheimer's but across diseases and persuade Congress and other investors that we are dealing with whole minds, Alzheimer's, mental health, Parkinson's, others, and lift all boats and not have a disease war where one disease competes another, but we lift each other.
And let me, do you still have your question? You were raising your hand. I want to give you the last question since you were patient.
Thank you. Hi, Anna McAllister. One of the things that we've seen, I have type 1 diabetes, helped start a patient hacker movement in the diabetes space. One of the things we've seen is that as sensors have proliferated and mobile technology has proliferated, that patients actually understand things that matter faster than researchers or physicians, because we see the data in real time in context. And there are some pretty bad biomarkers that have traditionally been used in diabetes. Those are starting to get better because of the role that patients have played in defining and creating a new science. Mental health to me seems really ripe for that kind of input, given how really bad the markers are for progress and disease. And I'm just wondering what kinds of efforts are being made to include patients and caregivers, depending on the specific disease, in defining the science.
I can start. A year ago, we partnered with the Depression and Bipolar Support Alliance, and we asked a group, it was open to the nation, but we asked, what are the research questions that matter the most to you, and what does wellness mean to you? And in that, we heard a lot that matched some of the studies outside, but really speaking to life as what mattered the most, and that those biomarkers, and as the DBSA has continued to work with focus groups, drilling down to understand that occupational markers and engagement in daily activities are probably better and more meaningful outcomes and predictors of where someone is in mental health wellness.
Do you want?
Yeah, just very briefly, I can tell you, we do not have a single research project where we have not talked with patients. I don't think you can develop anything if you've not talked with patients what they need. So at the foundation of everything we do should be the need of the patient where they want to go to. You talk about another point for the diabetes, that is this direct feedback with wearable and monitoring. We have to develop that. So I think for wearable devices, we are very engaged. We really want to move that forward. We are trying to use that more and earlier in studies. And as well, we have to develop the algorithm. And obviously, developing an algorithm will always only go with someone wearing it. So that is then your patient. So I'm fully with you. That has to be a partnership, and it has to be interactive.
Thank you to the panel for your candor and for your as complicated and intractable and much harder than going to the moon. I think you've given us some hope that there's deep thinking and there's real possibility here. So thanks very much, and thanks for sitting through this and for your sharp questions. Really appreciate it.
Thank you.
Thank you for your leadership.